we're going to start today working on chapter 8. And this is, for the most part, going to be reviewed for you guys because you did this a little bit in Algebra 2 last year also. We're doing 8.1 on sequences.
I like sequences.
Wait a minute.
8.1 on sequences. First of all, an infinite sequence, some definitions first. A function whose domain
Do you have this in layman's terms, man?
is the
What? Yeah, it does.
Discordant.
Can you fix the S and whose, please?
That S doesn't really look like an S.
Oh! No, the other
No.
S.
No, the other S.
In whose?
In whose?
Four.
oh my gosh.
I gotta go watch this video.
It's gonna look good.
That's what we always tell ourselves.
I'm gonna put that up.
An infinite sequence is a sequence or a function whose domain is the set of positive integers. So an infinite sequence means it's a string of numbers that can go on forever and ever and ever. So its domain is every set of positive integers because we call the first number in a sequence, we call it term 1. The second number we call term 2. The third number we call term 3. The fourth number term 4, and it can go on infinitely far, so we call it an infinite sequence. It has values that are called a sub 1, a sub 2, a sub 3, a sub 4, and they go on forever, all the way out to term a sub n, and then they go on after that too. So the point is just that, you know, if you're talking about the 10th term, you call it a sub 10. If you're talking about the 52nd term, you call it a sub 52. Notice I'm saying sub 1, sub 2, sub 3, sub 52, because these little numbers down here are not, by the way, this is a comma, not a 21. I do a very good job of writing my commas.
No.
But they're subscripts and they're just they're not superscripts, they're subscripts. So when I say a sub 2, I'm not talking about a squared, I'm talking about term 2, which is just denoted like that. Can I flip pages?
See. Why do you like so many?
The domain.
Oh.
I got one. There's like 5.
If the domain is the set of the first n positive integers and the sequence. In other words, if I give you that this sequence has specifically 10 terms in it, it doesn't have an infinite number of terms in it, what do you think it's called?
Finite sequence.
A finite sequence. But
Is
it's a
the n
finite
like
sequence
X?
because it has, what'd you say?
Is the N like an X?
The n is just a
It's like a number. What is
like an x, it's not necessarily a variable, and it's
What
just
is
a
it?
generic letter that represents, like, if there were 10 numbers in the sequence, then n would be 10. So sure, it's like an x. We usually use an x when you're solving an equation. You're not really solving an equation here. N is just used to represent the number of numbers that you have in a sequence, the number of terms that you have in a sequence. All right, so then the sequence is what we call finite, because it has a very specific number of terms in it. That was finite?
No, it's finished.
Infinite and finite. Okay, we'll call it finite.
Okay.
Alright. An example. If you have a rule, a sub n equals 4n minus 7, and your job is to write the first 5 terms. You would write them like this. A sub 1, the first term, a sub 1, would be 4 times 1 minus 7. You okay with that?
Yes.
You just replace the n with the 1. If you do the second term, you would do 4 times 2 minus 7. The third term would be 4 times 3 minus 7. The fourth term, take a wild guess what the fourth term would be.
8 times 5. Good one.
4 times 4 minus 7. The fifth term would be 4 times 5 minus 7. Now, this one especially would be very, very easy to calculate, just, doing mental math. 4 times 1 is 4, minus 7, negative 3. 4 times 2 is 8, minus 7 is 1. 4 times 3 is 12, minus 7 is 5, etc. But you certainly can just go to y equals, type in your rule for x minus 7, make a table, and the table will give you, whatever term number it is that you want. Okay? Yes? 4 times 4 is 16. Minus 7 is 9. 4 times 5 is 20. Minus 7 is 13.
They go up by 4 every time.
Why do they go up by 4 every time?
Because there's a 4 right there.
Because there's a 4 in the rule next to the
So
variable, which really means that the 4 is what we call a what? Think back to Algebra 1. The 4 is
multiple.
oh, you act like that's just like,
That's gone.
years and years and years ago.
I remember what
That was
4 is what we call the slope.
Nope.
4 is the slope. So that just means for each step of 1 that you take, your answer is increasing by 4. Slope is the same thing as, the slope is 4, that's the same thing as 4 over 1. So every rise of 4, you're running 1. So every step of 1 in my sequence here, my numbers are going up by 4. Alright, let's do another one.
Well, we need to know about the slope.
No, because you already know it. It should just be right there at all times.
That's what I just said. Do we need to know about it?
I don't think that we really talk about a lot of stuff in terms of the slope in this unit.
Okay.
All right. What about this? Another example, a sub n is equal to 5 plus negative 2, notice my use of the parentheses, negative 2 to the power of n. And I again want you to find the first, let's just go out to the first 6 terms. Now, you certainly could grab your calculators right now, type it in, make sure if you do that, that you are putting parentheses around the negative 2. And then you just calculate the first the first 6 terms. So in this case, the first term is going to be 5 plus negative negative 2 in parentheses to the first power. A sub 2 is 5 plus negative 2 to the second power. A sub 3 is going to be 5 plus negative 2 to the third power, etc. Now I just want to talk about this negative 2 being put to random powers. If you put negative 2 to the first power, that just means negative 2. So you really have 5 plus negative 2 here. What is 5 plus negative 2?
3.
So, yeah, three.
It's 3. All right, now when you put a negative number to a power of 2, the negative 2 becomes positive. So what is negative 2 squared?
4.
It's going to be a positive 4. So now we have 5 plus 4, which is 9. Now, this one we have 5 plus negative 2 to the third power. My point of this conversation is when you put a negative number to an odd power, your answer is going to be negative. All right, so here we have 5 plus negative 2 to the third power. Well, negative 2 to the third power is actually negative 8. Then we have to add 5 onto it. So 5 plus negative 8. What is 5 plus negative 8?
Negative 3.
It's negative 3. So A sub 4.
And then it switches from positive to negative.
Yeah, now again we're going to have another positive number. So we're going to have negative 2 to the fourth power. Well, negative 2 to the fourth power, I believe, is a positive 16. And then you have to add it on to 5. Well, what is 5 plus 16?
21.
21. And then you need to find the fifth term. So your fifth term is going to be 5 plus negative 5 to the power of 5. I don't know why I just said negative 5. Just thinking the power, it's not negative 5, it is negative 2. So negative 2 to the fifth power is negative 32. Negative 32, and then we have to add 5 to it. What is negative 32 plus 5?
Negative 27.
27. So it's flip-flopping between a positive and a negative. The only time it didn't happen was the first term is because when we put negative 2 to a power of 1, it was not more negative than the 5 was. All right, then the sixth term, a sub 6, is going to be 5 plus negative 2 to the sixth power. Well, negative 2 to the sixth power is a positive 64, right? I think.
Yeah.
Yes.
And you get
A
69.
positive 64 plus 5 is going to get you a positive 69. Did anybody in here type the rule into the calculator?
Yeah.
And did you get these numbers? Okay.
Yep.
So obviously a lot easier than doing mental math. But I did want to talk to you guys about how putting these negative numbers to different powers. If the power is odd, you're going to get a negative number. If the power is even, you're going to get a positive number. All right. This is kind of what you're going to need to do today. I have one more example I'm going to show you. And more just because I want you guys to be comfortable typing it into the calculator. But also, well, let me show you what I mean by this. Can I flip screens?
Yes, please.
What is so funny? I feel like you're being rude and talking while I'm trying to teach and
Oh no, it was
laughing and.
no, not really.
Alright, so we have a sub n is equal to, we have negative 3 to the power of n divided by 2n plus 5. Now, in a case like this, you're going to end up with terrible fractions, and when you make a table on your calculator, it's not gonna give it to you in fraction form. It's gonna give it to you in crazy decimal form. And I don't want your answers in decimals. I want your answers in nice clean fractions. So sometimes relying on the calculator to make a table isn't gonna work for you. You're gonna have to go back to the, doing the math. So find the first 5 terms. Let's find first 5 terms. Now, if you want to, you can type it in, but I am going to tell you that in this case, you're going to get crazy decimals. I don't want decimals. I want them in fractional form. So the first term, a sub 1. A sub 1. You're going to have negative 3 to the power of 1 over 2 times 1 plus 5. So What is negative 3 to the first power? Negative 3. So you're going to have a negative 3 on the top. Divided by, on the bottom, we have 2 times 1, which is 2, plus 5, which is 7. So we have negative 3 sevenths. Second term. You're going to have negative 3. What's going to happen to my numerator now when I put a negative number to an even power? It's going to be positive. Thank you. Yes. All right, so negative 3 squared is positive 9. And then the bottom, 2 times 2 is 4, plus 5 is 9. So in this case, we have 9 over 9, which is 1. Third term. You know, the numerator is pretty easy to figure out. You don't have to keep going in and plugging in, you know, a negative 3 and putting it to a different power. The powers are going from negative 3 to 9. What's going to happen after 9? We're constantly multiplying by negative 3. It's the negative 3 in the numerator that keeps getting a different power. So we're putting it to the power of 1, then we're putting it to the power of 2, and then we're putting it to the power of 3. So we're actually we keep multiplying by 3 again. So if a sub 2 has a numerator of 9, a sub 3 is going to have a numerator of 9 times 3, which is 27. But what kind of 27? It's going to be a negative. So we're going to have a negative 27. And then on the bottom, we're doing 2 times 3 plus 5. 2 times 3 is 6 plus 5 is 11. Now to find the fourth term, just take the numerator, multiply it by another 3, but know that it has to be positive. In other words, take negative 27 and multiply it by negative 3. What is that?
Positive 81.
Positive 81. And then on the bottom, we have 2 times 4, which is 8, plus 5, which is 13. Do you guys see the pattern in the bottom?
Yes.
Yes. So the bottoms and the denominators are going from 7 to 9 to 11. So we know that this denominator, the next denominator, is going to have a denominator of what?
15.
What?
11.
Oh, I'm sorry. This one has a denominator of 13. Yes, this one is going to have a denominator of 15. Why is it going from 7 to 9 to 11 to 15?
Slope.
Because the slope and the denominator is, look at this right here. This right here has a slope. That is our slope of 2. That means that the denominators are going to keep going up by 2. All right, so what's my numerator here? First of all, is the numerator going to be positive or negative? It's going to be negative. And all you have to do is take 81 and multiply it by 3. That is
243.
243. All right, I'm pretty sure that this one can be reduced. So always check for things like that. I believe that negative 243 divided by 15 is a reducible fraction. What is it?
If you multiplied it by 3, then you could. It's 81 fifths. Yeah.
81 fifths. Negative 81. Alright, so be watching for things like that. I don't think any of the other ones that have shown up so far were reducible, except for 9 over 9 obviously is equal to 1. So that's what you need to do today. Not so bad, huh?
Not